Hello everyone, welcome to the NN Classroom. Today I'd like to share with you a past paper question from 2018 Time Zone 0. Question number 5 relates to the topic on atomic structure. Topic 2 asking for like this. The values for the first 3 successive ionization energies of 2 different elements X and Z are given. So that's why here you have 2 elements and the successive IE for the first 3 ionization energies. So I think students should first know what is meant by successive ionization energy. So that means I now continuously to withdraw 1 electron and 1 electron one by one away from the same element, right? So you can see the energy requiring is always be increasing because of the increasing effective nuclear charge, right? And asking which pair of elements can X and Z be representing. So possibilities, right? So obviously this is a question related to asking you whether you can look at from the successive IE and judge the group number of these elements, right? So first of all, we can first identify the group number referring to this element, right? So lithium obviously is referring to group 1, beryllium is group 2, and lithium group 1, yeah, and carbon is going to be group 4, right? Makes sense, yeah, according to the periodic table. So now let's see. The technique is, remember, we are always looking for the huge jump, looking for the huge jump in the successive IE, SUCC, ESSIV, in the successive IE, right? Why? Because whenever there's a huge jump, what does that huge jump of the IE means? Means now the electron is taken away from a shell which is much closer to the nucleus, right? So as the electron is now located in a shell closer to the nucleus, it means it's now switching the shell. So when you switch the shell, the previously electron numbers will be reflecting your group number, right? So let's imagine if I'm having, let's say, sodium, right? You can imagine sodium is of 281. Obviously we know the electron arrangement. So that means after taking away the first electron, so this is taken by the first IE, right? And then the second IE will be having a huge jump. Why? Because now the second IE will be taking away the electron from the shell that is much closer to the nucleus, right? Because in shell number 2 versus the shell number 3 at the very first beginning. So that's why there will be a huge jump in terms of the IE between IE1 and IE2 for the case of a group 1 element. So if you understand this perspective and the reason behind, because electron that is closer to the nucleus has much stronger effective nuclear charge to be attracted by the nucleus. So that's why it is much more difficult to be able to take away the electron. So more energy must be required to do so, right? So that means we're looking for the huge jump, and so that huge jump will be leading to the understanding of the group number of the element. So if you understand this perspective, you can see first for element X, right? The first IE is 520 is okay. But then, starting off with the second IE, you do see that here having a really huge jump, right? From 500 something all the way up to 7,000, right? 7,000. So here having a big jump, you see that, right? Because you can also compare. From the second IE to the third IE is not as that multiple as the jumping, right? From 7,000 to about 11,000, right? So if you compare, here having like many times of multiple, right? So that means we can conclude element X is so similar to the case like sodium, right? That having a huge jump between the first IE and the second IE. So which means the outermost shell electron of element X is going to be 1. So with this perspective, we can already first confirm X can be lithium, but not beryllium, right? Make sense? Let's continue. For Z, if you look at the first 3 successive, you won't realize any huge jump. Let's see. From the first one, so 1090 to around 2350. So that is just like a double. So that is not as much as the multiple as we can see from the previous element X, right? And also from the second IE to the third IE, there's no big jump. Yeah, maximum is just a double, right? Double doesn't mean a big jump. Big jump at least like this, right? You can see almost like 8 times of jumping. So that's why in this case we can confirm that Z is not going to be group 1 and not going to be group 2, right? Again, not going to be group 1 because from IE1 to IE2 no big jump. So here does not have a big jump, so not group 1, right? So from IE2 to IE3, here again no big jump, so that is concluding that not to be group 2. So not group 1 and not group 2, so eventually can only be group 4 from the given situation. So that's why the answer for this case for double circle will be B.